Okay, in this short video we'll be looking at metallic bonding and describe bonding in metals. You should be able to do that by the end of this little video, and also be able to explain why metals conduct electricity. Okay, so let's start off with let's say a group 1 metal, lithium, sodium or potassium for example, which has one electron in its outer shell. If you could look at the structure, part of the structure, you would see something like this. You'll have positive ions surrounded by these electrons which have come off the outer shell of each of the atoms. So there's 9 atoms here, 6, 7, 8, 9, and there are 9 electrons. These are the electrons here, the dots. Right? And overall you notice that 9 positives and 9 negative electrons, no charge, cancels each other out. So we have these positive ions are called cations, positive metal ions called cations, and these electrons here are called the delocalized electrons. Delocalized. They are not local to any atom and they can travel about within the structure. They can jump on one atom, jump off it, jump on another atom, etc., or they can just float around the whole structure like so, or continuously going around in the metal. Okay, and it's the attraction between these negative electrons and the positive cations which holds the whole metal structure together. That's the glue, if you like. That is the metallic bond, the attraction between the negative electrons and the positive ions. Okay, what happens if we have, let's say, a group 2 element or a group 3 element which has 2 electrons in its outer shell or 3 electrons in its outer shell? Here's an example, group 2 element. Right. This time the outer 2 electrons are lost, and so you have twice as many electrons as there are cations. Here's 9 cations again. This time there are 18 delocalized electrons. Greater charge density, if you like. Now you can imagine the attraction between the 2 plus and the electrons is going to be greater this time, and therefore you might expect the melting point of this metal to be higher than the previous one, and that would be the case because of that greater attraction. Greater cationic charge, greater amount of delocalized electrons. Okay. Again, you notice overall that the charge of the whole metal is 0. The electrons cancel out the positive charges. Right, so we've had a go at describing the bonding in metals. Sea of electrons surrounding cations. Okay, one more thing. These delocalized electrons sometimes can be called a sea of electrons. Right, all these electrons here. A sea of electrons. They can also sometimes be called free electrons. So you've got several words to describe these electrons: delocalized, a sea of electrons, free electrons. All right. Okay. Now let's try to explain why metals conduct electricity. Oh, come back to that. Right. Let's try to explain why metals conduct electricity. Well, these electrons here are able to flow through the metal. So if you was to connect a negative terminal at one end and a positive terminal at the other end, perhaps a metal in a circuit, then electrons will come out of the battery, go through into the metal, and then out and back into the other side of the battery. So basically what's happening is electrons are flowing through the metal. So what do we need to know? We need to know that electrons flow through the metal. Through the metal. Okay, so that's basically what we need to know, why metals and how metals conduct electricity, the flow of electrons. Now if you've got twice as many electrons in your metal, then there's going to be a greater flow, greater charge, a greater flow of electrons through the metal. Okay, therefore this metal would conduct better than, for example, the sodium or the group 1 element would. Okay, if you've got aluminium, which is in group 3, that's got 3 outer electrons, and therefore you've got a greater charge, a greater number of electrons still, greater density of electrons still, therefore there'll be a greater flow of electrons. Therefore aluminium conducts better than magnesium, which conducts better than sodium. Alright, okay, that's fine. Let's summarize what we've just gone through. A sea of delocalized electrons surround a lattice of cations. So you might see that word lattice. It just means a regular arrangement of positive ions. Electrons flow through the metal, hence we get electrical conductance. The outer electrons get detached off the metal atom. The attraction between the delocalized electrons and the cations is the glue or the bond that holds the metals together. Again, you might see this word in books as well, glue. Okay, that's just the attraction between the negative electrons and the positive cations. Okay.